Welcome back, everyone. Now, we've spoken a little bit about average velocity, average speed, instantaneous. Now let's get into the nitty-gritty, into the specifics, so that we can fully understand what we're talking about, okay? So what we're going to do is we're going to look at uniform speed and velocity. So I've got a little animation for you. So here we go. Now, what we're going to see is we have a person on Father Brown, on a bicycle, and we're going to start to moving. And what I need you to pay attention to is on the right-hand side of the screen over there, there's going to be a speedometer. It's simply something that allows us to see how fast he's going. Okay, so I'm going to let him start, and off he goes. And we're supposed to stop it when he goes past the umbrella. We're not going to. But as you can see, his speed is staying constant, and it's just over 3 meters per second. That didn't change. Now, that's a speed because I haven't put a direction in. We didn't say which way he was going. But if I go, well, he's going to the right, that means he had a constant velocity of just over 3 meters per second to the right. Does it matter how fast he's going? Well, let's see. Let's make him go a little bit faster. Okay, just because we can. So there we go. Ooh, much faster. And if you look there, he's going at 6. Still, constant motion. His velocity isn't changing. His speed isn't changing. Okay, that means it's constant. We can do one more. Let's try one more. Let's see. Oops, got to reset him. Let's see how. Okay, let's go to 10 just because we can. There we go. We're supposed to time how fast he's going, but we're not going to. I just want you to see. Oops, he's going at 1. That's not what I wanted. Went too far. There we go. Much faster. Much faster. But still going at a constant value. So he's still going, in this case, it's just over 8. It's probably 8.5. Constant speed. Constant 8.5 meters per second. Don't care about direction. Constant velocity, because we can, oh, and it finished. Constant velocity, because he was going to the right. Okay, so he finished. He ran out of space. He was tired. Okay, so that's uniform. Let's talk about what happens when we have changing velocity and changing speed. So it's not the same the whole way through, and we want to be able to work out how we get the average and the instantaneous, okay? So I've got another animation to show you. So here we go. I've got a car, okay, over here. Now with this one, I can't change how fast it's going to go, but that doesn't matter. You're going to see the car going to the right, so we're going to take right as that direction, and it's going to speed up, so the car's accelerating. What I need you to take note of is what's happening on this graph, because that's the important part, okay? So let's see him go. There we go. He gets nice and fast. Off he goes. There we go. And done. Now, if we look at this graph, we can see as time goes along, he gets faster and faster and faster. So he covers bigger distances in the same time interval. So his velocity is constantly changing and his speed is constantly changing. If I wanted to get average, I would simply take distance divided by time. Okay, that would be the first thing I would do. I'd take the whole distance divided by the whole time. That gives me his average velocity. If I want to know how fast he was going at a specific point, we have to use what is known as the tangent. I need you to see what happens with this blue line. So if I go and I say I want to know what the velocity is at that point at 6 seconds. This line has now drawn a tangent, this straight line. I use that straight line to find the gradient of the graph of the straight line. That gradient gives me the velocity at 6 seconds, exactly at 6 seconds. So that's the instantaneous at 6 seconds. So if I could measure it, so like a speed camera, okay, which measures the exact velocity as you go past it, that's what that would do. If I go to 8 seconds, can you see the gradients changed? This has become more steep, which is what we expect because it's getting faster, okay? I get there, and it's even steeper. So as we go, this line, this straight line, gets steeper and steeper and steeper. To calculate average, what we could do is work out the gradient at every second, every point of this graph, calculate all those gradients, then add them all together and divide by however many we calculated. But let's be honest, that's a lot of work. It's just easier to take total distance divided by total time. You'll get exactly the same answer. Let's do some calculations on this though. So here we go. I took some screenshots of the motion. Okay, it looks a little different to what we just created. So this one goes a little higher, it doesn't matter. But at 5 seconds, I want to know what the velocity is. So at 5 seconds, here it is. I'm going to work out the gradient. When you work out the gradient of the graph, you can use any points on the graph as long as they physically sit on the line. When you have a choice, find ones that are easy to look at. So I'm going to use this point over there where my distance, so this would be my position 1, okay, my initial position is 0, because that's 0 over there. My time, so this is T1, so that's 2 seconds, is 2.5 seconds, okay? Now we look at it, and if I look nicely, I can use any point. So I could use this point over here, but I look at the graph, and it's not quite on a line. So getting the distance is a little difficult, and we look all the way. In fact, this is why I chose this one, is this is nice dot on the line, where if I go backwards like this, and you use a ruler, that's where it sits. This is 50 because of the scale, so that's 60 meters, and my time is 5 seconds. We're finding a gradient, so we go gradient. In this case, please, and this is where it gets a little strange for us, because in maths, we would use y1 minus y2 over x1 minus x2. We can't use y's and x's in science because they have meaning, which is different to maths. When we look at the x-axis here, this is position. Sorry, this is the y-axis, not the x-axis. The symbol for position, we're using x, okay? So my gradient is the change in the x over my x-axis is now time, so it's changing time, okay? So we're going to go, we need to keep those two together and those two together. That means we're going to do 60 minus 0 over 5 minus 2.5. Please be careful here for me. I know, and you know, that 60 minus 0 is 60. But you've got to show me that you minus the 0, because the 0 is important. It has meaning for us, okay? We're going to need to use our calculators for this. So we get our calculator out, and we're going to go 60 minus 0 divided by 5 minus 2.5, and I get 24. So over here, 24 meters per second. At the moment, I have calculated an instantaneous speed. I want instantaneous velocity, so I need to add in direction. And if we think about our diagram, it was going to the right. Okay, so at this exact moment in time, it was going at 24 meters per second at 5 seconds, okay? Come here. Okay, it doesn't want to. Let's go there then. Let's see what happens when we get to 7 seconds, okay? So here's my 7-second one. 7 seconds, and the distance is over here. So if I look at that, that's 120. And we need to find another point that'll work. And if I look at it, I'm still going to use that one. It makes sense to use the 0. And in fact, if you can use a 0 point, use a 0 point. Make your life easier. Don't try and complicate the calculations, because complicating them complicates them. Okay, complicating them makes them more difficult for you. Make it easy for you. That's what we want. So let's see what we've got. So my first position is 0, and my first time is 3. So that's 0 meters, that's 3 seconds. My second position is here, and we just saw that that's 120. And oh, no, that's not 3. If you look at that, that's wrong, actually. I'm hoping some of you noticed that's not 3. That's actually 3.5. So let's make sure we write it down right, otherwise we're going to get the wrong answer. Do you see that? It's 3.5. Be careful, okay? My second time, we said, was 7 seconds. Okay, well, we've got enough information. We're still going to find the gradient. Okay, which is my change in x over my change in time. So we're going to go 120 minus 0 over 7 minus 3.5. Now, I know that some of you probably don't need to show all the working on the calculator like I do. I just don't want any of you to get lost with where I get the answers from, okay? We don't judge how you do your calculator work as long as you get the answer, okay? And everyone does this differently, and I know I probably use the calculator slightly differently to the way you do, or your calculator has a slightly different setup. It doesn't matter. So I've got 120 minus 0 divided by 7 minus 3.5. Oh, and remember, we can't leave it as a fraction. So that gives me 34,29. Okay, 34,29 meters per second to the right. It's a steeper gradient. It's going faster. It's what I expected. Okay. We could do the next calculation. We're going to run out of time, so I'm not. But we could do exactly the same thing here. We have 9.5 seconds, and this would be 230 meters. And I probably wouldn't use this point because that time's a little difficult to see. I would use this point, 8 seconds, and 150. Maybe we can just do it. Doesn't want me to write it there. Stop it. There we go. Okay, now I can get it to write. So we would be going 230. So watch, we're just going to write it. We'll do it quickly because it's important. changing x over changing time. So it's 230 minus 150 over 9.5 seconds minus 8. Definitely need my calculator. Can't do this in my head. 230 minus 150 divided by 9.5 minus 8. And we get 53,33. Much faster. And that's what we expected, and it's a velocity, so it's going to the right. All the time it's going to the right, still positive gradient, okay? So, average speed would be my total displacement divided by my total time. So if we look at it, it's 240 divided by 10. Okay, so average speed, oh my word, I'm going to run out of time, is going to be 240 over 10, which is 224 meters per second. My average velocity is going to be 240 divided by 10, 240, that's 24. That's why you use a calculator. No, one. So that's 24 meters per second, right. Same value, one has direction, one doesn't.